Our presentation is about uncertainties in the meltwater runoff of the Greenland ice sheet due to changes in the firn structure. This topic is of great interest since the Greenland ice sheet has become the largest mass contributor to yearly mean sea level rise over the last decade, according to the IPCC. This increasing mass contribution is mainly caused by increasing melt rates. Additionally to increasing meltwater runoff, there is evidence that point into the direction that strong melt events also influence the buffer capacity of the firn layer in the accumulation zone of the ice sheet. Until recently, it was thought that surface meltwater in the accumulation zone mainly percolates into deeper firn layers, where it could refreeze during colder periods. This process was thought to buffer mass loss from higher regions of the ice sheet for years. However, there is increasing evidence from field studies that surface meltwater in years with extraordinary melt only percolates a few meters into the firn layer, where it refreezes and forms ice lenses. These ice lenses block lower parts of the firn layer, and it comes to meltwater runoff long before the whole firn layer is filled. Therefore, the melt capacity of the firn layer might be smaller as initially thought.